Okay. All right, everyone. Well, it's great to see so many smiling faces here. Uh, anyone that's hungry, we do have pizza, and Joe got a couple other items for us. So I'm just going to give a little spiel. My name's Blake Wingard, for those that don't know me. I've been working professionally for a little over a year, got some CAD experience, and so my goal here is to kind of pass it along to you guys. I'll be taking you through the design process. We're not necessarily intending for this to be a step-by-step follow along exactly live, but there will be recording. We'll publish it to YouTube and share it with you guys, so if you want to try and follow along at home, you can. But for today, we're going to go from schematic all the way to layout. And then the goal after that is we'll order the board that gets designed. Maybe I'll tweak it a bit behind the scenes. And then 3 weeks from now, on October 14th, we'll meet back in 267.
We actually have an improvement.
Okay, we may have an improved venue, but right now 267. Improved venue. Yes. Okay, so we might have a different location. But regardless, 3 weeks from now, we'll meet back and solder the boards that we ordered. So we're using Eagle. Part of the reason I chose it is I know some of the faculty have used it before. You can get a student license for it and get most of the professional features. My work uses OrCAD, but I don't think there's a student license for that. And fundamentally, these skills translate between these softwares. Most of the fundamentals are still there. So, if you guys get any questions, just to note, you all are on camera, kind of, as your voice may be picked up. So we're just going to dive right in. So when you download Eagle, this is the control panel. And what you can do is start a new project. And the circuit we'll be designing today is a binary counter. Oh, it doesn't like that. Okay. Oh yeah, because I already have one. So let's get a different name. Binary counter 2. Professional naming there. We'll start with a new schematic. So this is what you get greeted with. We have a few tools here on the side. One thing we're going to point to, if I can find it again, is a title block, which is optional. I don't think I have it on this machine. No, I do not, unfortunately. So let me go back and show you what a title block would look like if you have one properly set up in my other design. Projects, binary counter 1, there we go. And we'll let it load up. So this is a title block. It is for nothing more than posterity and to feel professional. It does not serve any functional purpose beyond that. And yeah, so this is what we'll be designing. As for whatever reason, I don't have the title block in my library right now, so we're not going to be using that today. So let's go back to what we are doing. And I must have forgotten to save it. So we'll do that one more time. There we go. Save it this time. Okay, so let's get started. So to add parts, you have this little model here called Add Part. And we'll start with just a simple component. These are your libraries. And the one I'm going to use for resistors is from Adafruit. Well, we're not going to do it that way. There we go. So Adafruit. There we go, Adafruit. So Adafruit just has a nice generic list of resistors. And my mouse has died. That's okay, I can work with the trackpad. So these are your various resistors. And one thing you want to keep in mind for design, if we look right up here, these are sizes. And that's important when you go to the PCB layout because it can specify the size of the component that you're putting down. So I'm going to pick this one. There we go. So you see here we have our schematic view, which will have the name of the component and its value. And then this will be the physical layout. Now this one's kind of a combo package. So it has 08, 05 for those that can't see it because it's a little hard to see, and a through-hole mount. So you see here it's got both the pads for an 08, 05 component along with leads for you to put a resistor with little legs. For those that want to see, I do have a board here that has 08, 05 resistors on it, just so you guys can see how small those are. There are the little resistors below the LED. I'll get this to pass around. That's an 0805. 0805 is a standard unit. It is, if I remember correctly, I don't think most of them do, as that information was for those that RSVP'd on the event page. And I only got 4 RSVPs there. I think that was partially advertisement. Download and install took me about half an hour when I did it. Well, so the download itself was probably like 10 minutes with a 10 megabit speed, so it should be faster here, but the install itself still takes a while, and then you have the license approval process. So that's why this is also being recorded. For those that don't have it, they can do it later. So, oh yeah, that mouse is dead. All right, so where was I? Oh yes, so you got component sizes, all that good stuff. For a binary counter, we're going to choose, my trackpad is not very sensitive, unfortunately. So we are going to choose a CD 4027. Now, unfortunately with EagleCAD, by default, this is how it works. You type in the string, you get exactly what you search for. So if you're off by a little bit of your component, nothing shows up. If you can read this little box here, it does give you a little hint that there's this thing called wildcard, which will let you match any part of a string. Yes? I would love to use that mouse. It's all good. I have been blessed with an extra mouse from the audience. Give me a second. Do I have to turn it on, or? Maybe I'll try the other USB port. This one is fully charged. Thank you, sir. There we go. All right, so after some technical difficulties, we now have a functioning mouse. So, wildcard pattern. As I said there, nice little asterisk. We're going to add that. And that should maybe also add it to the front and remove the CD. There we go, my 4027. So it wasn't a CD. And this is our JK flip-flop. So if you've looked on my board that's been passed around a little bit, I don't know where, there it is right now. It has 4 ICs on it for 4 of these JK packages. Notice from our little schematics that it shows we have 2 of them. Now it isn't showing that layout for some reason, but I do believe this is the same one I used. So it'll probably show up in the, oh wait, here we go. There we go. So, a little screw up on my part because I'm not as familiar with Eagle. This little drop down gave us our 2 chip versions. Does anyone have a guess as to what's the difference between this D and this N? Anyone want to take a shot at what the difference is? You in the back. I saw your hand go up.
Second one you showed.
Yes, that second one is surface mount, which is the one I used. We will be using the dip pin solution just because it's a little bit easier to solder straight through than it is surface mount. And seeing as how I'm expecting you guys to have zero soldering experience, we want to choose the easiest option we can for this. So I'm just going to go ahead and double click it. And now I can come out here and place half of the chip. So I'll put it here and the other half here. And we'll stop there for now and come back and add some more later. And here we are. These are most of the pins for our 4027. Now if we come over here to Google, I'm going to Google the CD4027. And we'll come down here to our data sheet. And so one thing that could be important is you'd want to match up the pin numbers here with the schematic numbers here. And if you look closely, one thing you'll notice is that Q2 goes to pin 1, whereas here it's Q1. Thankfully, I checked these close enough. They do map pretty much the same. It's just they flipped Q1 and Q2. So for all intents and purposes, these chips will function identically if we wire it up to this chip we're going to order. Now this is the surface mount. I think the dip pin solution is further down. But without further ado, let's carry on. So we're going to do a 4-bit binary counter. If everyone's had a chance to look at that board, you'll notice 8 LEDs. Part of the reason we're going to do 4 is you guys will get to see a nice little rollover effect. You don't have to push the button 256 times just to see it flip back to all zeros. So for that, we're going to need one more of these 4027s. Boop and boop. Okay. Next, we're going to pick ourselves some LEDs. And let's see if I can remember how to find LEDs. Aha, you see I got LED controllers here. Good, good. Okay, so yeah, usually when I don't know how to find something, Adafruit's got me covered. Shoot, 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 shoot. LED. And there we go. So this first LED here you can see is a surface mount. I don't see the chip package right off. I'm going to use through-hole LEDs, 1 because it'll be easier to solder, and 2 because I think they look a little cooler than the surface mount LEDs. But that's my opinion. Let's go with, I'm feeling the 5mm today. So, again, simple PCB layout. We're doing a 4-bit counter, so we're going to need 4 LEDs. So we'll just put these up here. And there we go. Now let's also grab, while we're here, some resistors. And I want through holes. And I'm going to see if I can find just a through hole. That's a big through hole. Don't necessarily want to use I think I like, I could just not be picky. This one. I'm going to use this one just because I like the way it looks. So, 4 resistors. At least right now, we're going to need, oh, I should point this out because I haven't yet. So when you got a component and you want to rotate it, right-click. That's it. So these resistors are going to be needed to limit the LED current. We're actually going to calculate its value in a little bit using the tried and true LED calculator method. It's fairly straightforward, but if you haven't seen it once, it might blow your mind a little bit. And we'll leave that there for now. So who knows how to calculate the needed resistor value for an LED? You in the front. Okay. Could you expand a little? Good. Yes. Yes. Good. So, to say that for everyone else, we're going to take the voltage drop of the LED, which will be the forward voltage. Now, I happen to remember that the LEDs that we're going to order have a voltage drop of 2.1 volts. Yes? Sure. Let's grab an LED spec sheet from DigiKey.
And there is nothing magic about this now.
No.
Lots of options.
And you know what? Well, I was going to say I might be able to grab the ones I ordered explicitly, but they're taking me. Here we go. Order. Now we have the fun process of waiting for your web page to load. There we go. And we will scroll down. Oop, did I scroll past it? Oh, I did scroll past it. I started on a lower page.
What is that? What is it?
The spatial distribution?
Yes. It's the big viewable angle for LEDs. If you really dig into LEDs, you can pick one color and have, but there are so many other possibilities for spatial angle, dome color, the other color. A white LED that looks like white LED may not even be white.
Is that reading the, it's only visible where that circle at the top is, or is it
In,
like the 0 degrees?
Yeah.
Oval looking thing?
I'm not going to speak, I would like to speak knowingly on this particular LED, but I can't, I'm going to say yes. Especially if you, now I think in this case, it might be a little ridiculous because you have these surface mounted, but if you have a recess, it would be definitely fair. Again, you'll see like 100 options, the devils in the details, and you'll actually go through this, that's what's different about a lot.
Yeah. You can really over-engineer an LED.
You really can over-engineer an LED.
So let's see, I think... All right, here we go. Forward voltage. So, okay, I used 2.1. What's the difference here? Typical max, I did 2.1 for safety, and this was done at a current of 10 milliamps. So that tells us two things. Voltage across the LED will be 2.1 volts, and the current draw should be about 10 milliamps. So I also know that for our power supply, we are eventually going to use 5 volts. So we'll bust out a fancy little Windows calculator here. 5 minus 2.1, that's 2.9, and then we're going to divide by 10. This is the hard part, remembering your zeros. I think that's 10 milliamps. Looks right.
Yes.
So we want about 290 ohms. I think I used 300 just for a little extra. It's not an exact science, it just gets us a ballpark. And so that's what we'll do. And to assign values to an LED, you can come over here to this little button, says value, click on it, and then click the component you want to give a value. So 300. And we'll do that for each and every one. Okay, and we'll zoom in a bit here. I am holding the control key while zooming with the mouse wheel, or sorry, scrolling with the mouse wheel to zoom in and out. And let's go ahead and wire these up. So we have this little button here named Net, and these will let us add our little wires to these LEDs. Let's also take the time to add a ground, and I believe the grounds are just here. We'll go with, I like this one. Boom, 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 and boom. And then we will, not the bus, the net. There we go. Wire these up. And so I'm going to be a little fancy for the LEDs. So I'm just going to place a little wire here. And then what I'm going to do is label this net. And so the neat thing is that you can label these nets as recognizable names. And so for LED 1, I'm going to call it, put it here. Select name. I'm going to call it bit 0. So effectively, as we can imagine, this is going to help tell us that LED 1 represents bit 0 on our binary counter. And then I'll show you how we're going to actually provide it a signal by doing the similar thing over here with the flip-flops. Let's continue. We're just going to do the exact same thing. I'm pressing escape to close the wire drawing after I place it. And then let's come over here with a net. Boom, 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 and then name them. Bit 1, and that, there we go. Bit 2, and bit 3. So that's our LEDs pretty much done. Now, when I did research for this chip, I wanted to pick out a chip that would drive these LEDs themselves. Sometimes your chip might be a little underpowered and not have enough current to drive your LED component, device, whatever. Might need some kind of driver. But if we take another look at the spec sheet in the max current, I want to say it had a max current, operating temperature, DC input current. It's always the fun part is finding it. Output high. Is this it? No. I might scroll past it. There we go. So when it's acting as a sink, it's output current, or excuse me, for 5 volts can run 1 milliamp. That's not the value I'm looking for. Was it IDD max? Yes. Yes. So there we go, 20 milliamps for 5 volts. Anyway, these chips do in fact provide enough, because if you don't, you might blow up your chip, and thankfully mine hasn't blown up yet. So who knows how to wire up? Well, I shouldn't go into that much detail. Let me show you how to wire up a JK flip-flop. So I assume everyone here that's electrical has taken digital logic. No? Okay, and you're mechanical. So real quick, the idea of a JK flip-flop is that it is a device that can store state. There's a bunch of circuitry magic that's going on behind the scenes. Your outputs are these Q values over here. And so if your output is high, Q would be high. 3 volts, 5 volts, whatever you choose for high voltage. And low would be ground. And then Q, you can't see it, but it has a little bar above it. This is the complement output. So if this is high, this is low. If this is low, this is high. And so the way we're going to take advantage of it is that if you take a J to K high, I believe I'll go interpretation on that. Every pulse of the clock will boop, 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 will make this toggle. So think about it. You get one clock pulse, this becomes 1, and then another clock pulse, this becomes 11. And we're going to chain the output of those JKs like so to the next clock. And so if you think about it, every time that Q goes high, and actually we're not going to do it that way, we're going to do the complement, but anyway, when that Q goes high, it'll trigger the next clock to also go high. And so that's why we're going to take the complement, so that when the Q goes low, the Q complement goes high, and that ripples down to the next bit. Does that semi make sense? At least seems logical enough that you can kind of follow. Any questions on that? You said it? Oh, okay. So we're just going to line all these up, and I might move it around a little bit. And there we go. And so the way we're going to control these as bits is we're going to come up here, and just like before with the LEDs, we're going to add a little net, give it a name. We're going to name this the same net yes as that. So now the output of that chip, when we actually go to lay it on a PCB, will tell us, hey, make sure I'm connected to the LED. And then we'll do that for each one. And of course, if I forget how this chip works, I'll just go back to my other sheet because I know that one's for the most part correct. There is an error on that sheet, and I'm going to point it out to you guys once we get to it. I did manage to screw up my first PCB made with Eagle. Yes?
So is there a grid or snap to grid that things that are just really good at laying this out?
It's just skill. No, there is a hidden grid. As a matter of fact, if I recall correctly, we can come over here to this grid button, change its size, and actually display it. So I am, as magical as that looks, there is a bit of assist going on there. So, bit 1, yes. Bit 2, and bit 3. Okay, so let's also do something else a little fancy. So I want this circuit that we had to do two things, just like it has two buttons. If you looked, it had an increment button, which we can imagine is for adding 1, and then a reset button, which should be clearing the whole thing. So for the way these work, you'll notice that there is an S and an R I didn't touch on. These are effectively overrides, meaning it doesn't matter what's going on here. This tells it, hey, set this chip high, which will be 1, 0, high, low. And the R says reset, 0, high. So if we want to have a reset button, we need to tie every reset of these chips to a reset button. We could draw each wire by hand. I am going to opt for just calling a net reset, and that will all be handled behind the scenes for me when we go to the layout portion. So let's do that. I might space these out a bit in a second. So let's add some labels. Boop. And name them. Reset. Now there is copying and pasting in Eagle, but personally I have found it a little finicky to where it copies things in ways that I didn't expect, so I'm just not going to show you guys how to do that. Especially when you get to the PCB, I may show that one, because if you copy, say, a via, it'll actually not only will it link them net-wise, but if you try to change the net on one via, it'll update the other via with the same net. So it behaves weird, which is why I'm not copying and pasting as much as I would like. And of course, let's just go ahead and add in. Once again, the clock signal is going to be our increment. There we go. And I can just name this directly. I'm going to call it inc. So I just discovered a little shortcut. You don't have to click the label. You can, in fact, just name the wire. Okay, we're part of the way there. Let's finish wiring up these JKs. So the set we're going to pull to ground. The reason being is that it's a general good practice that when you have ICs, you don't want to leave things floating because you may get unpredicted results, unexpected functions. So you want to actually try and set these pins to proper configurations. So for the set, we're just going to pull these to ground. Now this is sort of a nomenclature or standard I picked up from work, but my boss likes us to put our grounds down and then our voltage sources up. And so let's shift that around a little bit. And this we should be safe to copy and paste, but I'm not going to do that because I don't trust it. Yeah, we're going to need to move these chips around a little bit. So I'm going to highlight, I think it's getting a little cluttered here. So I'm going to press escape till I have nothing but this selected. Highlight that. I should be able to just move these. I missed some. Highlight it and move it down. And the name's moving with it, but I can just move that back later. There we go. So this is a good chance for me to segue into a slightly different topic. Is that not on this? It might be on the other one. Filter, design manager. Oh, here we go, selection filter. So you notice how I had some trouble selecting that name from the net, how I tried to move it and the wire moved instead of the name. This is our selection filter. And so if we want, we can come up here and select, I believe this is in the label group, but I also select the text by control clicking. And now I can't select this wire, but I can, oh, that might not be text, it might be something else. Let's select the wire instead. So if I want to just focus on the wire, I can just select this over here in the selection filter and move it. I don't know why I couldn't move this name. I may have had the wrong filter selected. We'll give that one more try. Yeah. Well, I'm not going to play around and try. Oh, here we go. Probably attribute. There we go. Okay, so this is an attribute. Excuse me. I didn't remember which type this was. Yeah. This is where learning your tool a little bit comes in handy. OrCAD's got different names for these type of things. I'll bet you Altium does. And you kind of just have to figure out, okay, this is an attribute, this is text, and then you can get a little fancy with the selection filter. But anyway, now that I have a little more room, let's finish off these sets. I'm going to have everything selected. There we go. I'm going to come up here, select that. And I'm actually going to do a Control-C and Control-V because I don't plan on renaming the ground. Now let's come into here and delete this little offshoot. Oop. And let's just clean up these things a little bit. Oops. I still have my delete selected. There we go. Make this just look a little bit prettier. You have to be a little OCD to survive in the engineering world. This might actually, oh yeah, this is a label. There we go. And select all, highlight, drag. There we go. Okay, next we have our JKs, and if I recall correctly, I don't think I have that schematic still open. No, I might open it later. But if I recall, we're just going to pull these to high. So we're going to come up here and just put a little wire up there. And there. Then we're going to go grab ourselves a VCC. I believe it's called +5 volts. So one of my criticisms of Eagle is that renaming sources is not really a thing. And so the way you get other voltage sources, if it doesn't already exist pre-installed, is you'd have to go and copy, paste, and rename it. It's just from the way they do things behind the scenes. Luckily, they do at least have your common ones like 5 volts, 3.3, and so on. Yeah, I'm going to have to get some more room for this. So we're going to highlight all of this and just drag it down. And so while I'm wiring these up tediously, do we have any initial questions, any confusions about the way Eagle works, what I'm doing? Oh, the wires? Okay, yeah, the dots are junctions, and they, for the most part, appear automatically. If, for example, we have them, you see how I deliberately attached it there and then added a junction, whereas if you just run the wire through, it doesn't make a motion. Yeah, and this is just notation, basically, if there's no dot, it's not connected to this. And it did it automatically, but I can come down here to junction and add one manually if I want to. So, a couple ways to do that. Yes?
I think one way it's the same deletion process as the highlight.
Well, let's find out. I can't say I've ever had to do that. So call this pin 5. And I might be able to come over here to my selection, choose junction, highlight, right click, delete. There we go. I had never done that before. So once you kind of get a feel for the way your tool works, some of these things become kind of intuitive. And then you go and swap tools and everything feels wrong again. Copy, paste. I do feel comfortable copying and pasting these global nets like this because I don't plan to rename them. Alright, so now we're running into a fun issue of me trying to move stuff without moving other things. So let's do that and that. It's a delicate art of selecting things you want and don't want. And for those that are familiar with computers, you may know that you can control or hold control and click other things to add them to your highlight. I'll admit that's probably not very visible. Okay, so you see how this is slightly more bright than this, or brighter than this? That means it's highlighted and this is not. So now that I've highlighted it, I go to move it. It falls along with it. That's just a neat little trick. It does work in File Explorer. So if you guys have ever wanted to select multiple files but wanted to exclude some, you can just go back and control click it. It was one of the life-changing shortcuts I learned. And now I just admitted that I didn't really know how to use a computer until I was like 20. That's okay. I didn't like that. Add that up. And then we'll come up here, select, oops, don't want that wire, control, paste, yes, and paste, boom. I'll delete that little junction. Okay, and this is, for the most part, the entire chip wired up. Now, if I recall correctly, I believe you'll notice, if you were paying very close attention, that some of the pins on these chips are missing. If you can actually read it. So if you look closely, you'll notice that there's mineral pin 8 or pin 16. Those are the supply pins. And I believe, I haven't tested it yet, but I believe that those will auto wire to your power and ground. But I do like to add them. And this is the part that I usually have to Google because it's a pain. It's one of those pains that you just have to learn with your tool. But we can go to Info, select the chip, and, or no. I'm thinking of OrCAD. My bad. That's OrCAD. So there is an extra tool here. Where is my extra tool? I know what it's called. I just can't find it. Invoke. So we click Invoke. And you see how we have this little third option here that we haven't seen before? We've seen the B, we've seen the A, but we haven't seen the P. That's where your power is. Why they do it this way, I don't know. So just to repeat, you click this Invoke, and then the part that has the missing parts you want, and then there you go. You got your power and ground. And that's for IC1. We're going to come down here and do it again for IC2. Let's come over here. Oh, come on. Then move. It is not behaving. This is the downside of these thin components. There we go. And we'll just wire these suckers up. Copy and paste the ground. I didn't want the whole wire. Clearly I'm having a skill issue with this copy and paste. And it's not centered because that would be too easy for me. This is the downside to being OCD, is that these things will haunt your dreams. There we go. And one more attempt with the supply. There we go. So now the VDDs are going to power and the VSS are going to grounds. And of course, we'll double check my circuit with my known working circuit. So now let's go to the buttons. And before we go to the buttons, I want to give a chance to embarrass myself. So for those that were looking closely at my board, you may have noticed that I scratched off a portion of it. This was the exact schematic. Who can see the problem with my circuit? I'll give you a hint. When I plugged it in, the LED would sometimes be on. I press reset and turn it off, but the increment would never work. Does anyone see why? So, this is the increment, and it is shorted with the reset. So basically, whenever I press increment or reset, it would do both of these at the same time. And remember earlier I told you this reset works regardless of what the clock is working it on. So effectively, when I press increment, it would reset. So if you look closer at that board, you'll see in between those two buttons, I took a razor blade and scratched away the trace. And then on the bottom, I added a resistor for the pull down, and it worked. So right here, power is going through that, and then it's just, but for whatever reason in my brain, these were separated. I don't know why I thought this was that. Probably had too much caffeine. But yeah, I had shorted. And so I had to modify this jump, yeah, they're connected. I tried to use the same pull down resistor for two switches. Forgetting the fact that when you pull it up, it's not like there's not magic diodes or something. So we're not going to do that. And we do have specifically picked out switches, and I am going to point this out. So Eagle has a lot of stuff, but it does not have everything you will need. So what do you do if you want to use a component that isn't included in Eagle? You could manage your own libraries. My solution is Snap EDA. They have a neat little desktop app. And it's, there we go. And you can actually take the time. So let me pull up these switches here. They are TL 1100s. Start with that and see if that pulls up my switches. No, that would be too easy. F160Q. There we go. So these are the switches these aren't the exact switches that we'll use. They have a few different styles. I used the one with the bar because, I don't know, I liked it. But this part is not natively in Eagle. So what I had to do was take this part number, come over here to Snap, click on it, and then I could take these pre-made packages, and I'm not signed in. Of course, I wouldn't be. I'm not going to bother signing up, but basically click on that. There's a little button that says install. And since I have the desktop app, there is an auto setup where it handles all the stuff behind the scenes for you to get linked with Eagle. I can't show that because I don't have a new laptop, and I didn't want to wipe the whole system. So, but this is one option. There are other options online. You just need to research and figure out which one you like best. This is free, so that's why I'm advertising it. So let's go back to our other schematic. Control O. I'm going to go back to binary counter 2, and boom. Yeah, okay, I don't care. So we come down to, there's my button, and it's just TL 1100. I could probably star, and we'll see if that shows up. Of course not. Okay, so we'll go Snap, and I may not have the library configured this. Let's check my library manager. Nope, I don't have Eagle on here. That's fun. I always love having to do this. Library, open library manager. It's probably under available. And then another fun thing is, because of the way my laptop is set up, I have 2 document folders. I have one with OneDrive and one for myself. Don't ask me why that makes sense. So boom. I imagine if you have a simpler setup on your machine, then this will just work. But of course, I can't be simple. So there we go, Snap EDA library. That is the managed library by Snap. I'm going to open it. And I think, there we go. I'm going to use it. So there you go. You guys got a secret tutorial of how to link this thing in case it didn't do it automatically. And yeah, now it should be in use. Let's double check that. It was called Snap. There it is, Snap. So now we can come back here to add part. And I am going to forget that 11 each time. And there is our little switch. So one of the reasons I picked this switch was to slightly dummy-proof it. These switches, you can flip them 180 degrees, but you can't flip them 90. So you can't accidentally short your high to your resistor, thankfully. Whereas if you get like a little square button, you might accidentally put it in the wrong way or something. You might get that mixed up. This just dummy proofs it. For my sake. I know you guys wouldn't get it wrong. Yes?
I was looking at Snap EDA's website.
Mm-hmm. Yes, I've used Snap EDA's website.
You want to take a second just to show the steps of how you go the other way to find the product there.
Oh, on the website?
Yeah.
Sure.
It's okay, it's too much of a departure, just looking at small things.
Yeah, if I remember correctly, and so we'll go look at the site real quick. I'll just put these in here and come back to them so I don't have to find it again. So if you don't want to use the desktop app, you can technically come here. And who knows, maybe I'll be logged in here. No, of course not. There we go. Let's see, what was that part? TL 1100 F160Q, I think. And that might have been my miracle of the day, so I better not go to the lottery. And there you go. Select that. And there's your symbol, there's your footprint. And there is this neat little auto import that takes you to the website and all that, but you can also just download it here for Eagle. And there's the library. It's a separate library, so you'd have to link that in like you saw me do with the Snap. Whereas if you use the desktop app, you just get a nice little managed library where all of it will be taken care of for you. So yeah, put this where you would put your other libraries, link to it, and you are good to go. Good? Just in case, is there any questions on that library part? Okay, good. Let's head back. And so here are our switches. And so the way we're going to handle this, we're going to do a couple things. We're going to move these switches for a little bit more room. And then we're going to pull. So the way I'm doing this is on the left side, we'll have our high side. Doop, doop. And then on the right, we'll put our output. And we're just going to link these to the buttons the same way we've been doing it with the LEDs by just adding little nets. And then eventually we're going to add a pull down resistor along with another little magic that I'll go and talk about in a second. So let's name this. This will be our increment. And this will be our reset. Now we're going to come over here. I'm going to copy this 5 volt. And of course I miss. Yes, there we go. All right, so pull down resistors. I'm just going to cheat. I should be able to copy this and modify it. We'll put it here and here. So before I get too far, you guys understand the idea of a pull down resistor? Does anyone not know what a pull down resistor is? Okay, so I'll explain this real quick. The idea is that if we don't pull this down, then this value could technically be in the microvolts, millivolts, who knows what. And so with a pull-down resistor, you are giving it a fixed value. This is ground. And we make it a resistor, so that way current, we do want to change it, current will hopefully flow to whatever we want to control to, because there'll be less resistance there. Going back to your resistor divider, current takes path of least resistance. So we'll make this something large, like I think I did 3K, 3.3K there. Good enough, considering that we have no resistor going that way. And so it's called a pull down because it's pulled down to ground. You had it going to the source, that's a pull up. So one more time, a pull up, the default value is high, pull down, default value is 0, and your switch should swap that. Good? Okay. Where was I? Oh yes, I was doing the wiring. And we are going to do something a little different with this increment switch. And we will paste this, and I will clean this up a little bit because I don't like the way that right here looks. No, I really don't like the way that looks. Okay. So we could technically stop here and the circuit would work. There is one little nuance. So for those of you that don't know, switches are mechanical. And what that means is they're not perfect. And so when you push a little switch, it's really hard to see unless you get an ultra fast camera to capture it. But I have seen it with one of those, like, I think it was just several thousand frames per second. But if you push the switch, you can actually see a little bounce with the metal contact. And so if you hook up an oscilloscope to capture the voltage out, you can actually see a ripple. And sometimes that ripple is bad enough that you can actually get multiple inputs. No, I'm going to draw with my hands. So one other thing you may have noticed on my board, if you look on the bottom, is I added a little capacitor because I didn't think about it, but this clock works on an up signal. So it detects it when it changes from low to high, meaning that debounce is big enough that it actually detects multiple presses with a single physical press. So how you fix that, there's several advanced techniques. I use the tried and true method of slapping a capacitor on it and calling it a day. And it worked. Why I didn't debounce before? Probably because it was midnight. I mean, I already shorted out these buttons, so clearly I wasn't thinking at the time. But ideally, if you're going to use a button with a sensitive input, you do want to debounce it. Now, I'm not going to debounce the reset because that is a simple, hey, if I'm high, I set everything clear. Don't really care about debouncing it. So we're going to cheap out on that. And a single capacitor is by no means the best method, but it does work. So let's set these resistors to 3.3K.
It's like basically like a duct taping, like whatever, like you have a, but it works.
Well, with what I did there, yes, I did physically tape it.
So like both
yes.
mechanical and
yes, that was a duct tape solution, but it worked. That's all that matters. As I reached into just some old components I had, probably from components that felt, I think I even found the capacitor like on a shelf randomly. It was just there. I don't know where it came from. Maybe from when I was teaching 316, I may have stolen the capacitor.
So basically, it also just dampens like the spikes, right? So
yes.
Completely remove it. Don't dampen it to where it won't detect the second, third, fourth.
Yes. Yes.
Okay, yeah.
So if you're doing something a little more precise, it's not recommended because those switches can wear out and the bouncing can get worse. And so you want to use something a little more stable. But this is a cheap board, so it'll be fine. It's a little more expensive solution where you start getting IC chips and all that fancy stuff. So I didn't add a capacitor to my last one. So I'm willing to bet you Adafruit's got a nice little solution for me. So probably under C. There we go. And we're just going to... That one looks right. Once I actually pick out the parts I'm going to order, I might modify these slightly, based on spacing and all that. But for now, for demonstration, this will be fine. And we're just going to throw that in parallel. It's not the best, but it works. And sometimes that's good enough. So we're just going to throw in. I keep wanting to press W for wire because that's the shortcut in OrCAD. But it's not the shortcut in this. I don't remember the shortcut for this. First world problems, I know. For this, where's my PCB board? I think I just slapped 10. Yep. 10 micro. We'll do 10U. There we go, 10 microfarads. Worked for me, should be good enough. Okay, and this, unless I'm missing something, is pretty much it. Now, one of you might call me up and be like, hey, Blake, what about that fancy little blue chip you got there? That is a custom, by yours truly, design. So for the power supply, I was faced with a difficult decision. I can't expect you guys to have power supplies at home, nice little things you can plug into a wall and attach with a plug. I can't ask you to be taking your laptop cables, cutting them up, and then sticking them there. So I had to think, what's the best way to do this? Batteries was a condition, but I didn't like how long they would last with the LEDs. And I wanted to do a USB port, but it was a tough ask for me to add a USB-C for you guys because they're very tiny pins, kind of hard to solder. So I found a nice little chip, and I think these might actually be from Adafruit. Let me double check on that. As soon as DigiKey decides to load. There we go. Yeah, Adafruit. I found this little chip right here. It's not that expensive. We don't have, luckily there's not more than 60 of you here. And so effectively what I did is once we get to the PCB layout, I took this part and I mapped it out by hand. Now it's a little bit easier because if we go to their website, they actually had Eagle schematics. So I could actually take it and measure it in Eagle to make sure I had the exact dimensions. Let's see if, there we go. Eagle CAD files are available here. GitHub, where all of your, well, anyway, I think this was it. Yeah, there's the board file. So yeah, I was able to come here, download it. I opened it up in Eagle, and I just individually measured everything I needed because I didn't physically have the chip, and then I laid it out in the layout by hand. So we're going to get to do that. It's going to be fun. We'll see if I can make that miracle happen twice. My biggest surprise was that it actually fit. Yes. Ah, yes, the bill of materials. You're a step ahead of me. So either way, I like that because all you needed was a USB cable, and so odds are good most of you have a USB-C cable lying around somewhere. If not, it's like $10 or less or more. I don't know. Cable one. Yeah, we may even bulk order this. No, batteries not provided, cables not included. So I was literally just about to talk about the bill of materials, and someone beat me to it. So after you finish laying it out, you'd want to generate a, ideally at this point, you'd go take out a breadboard, lay out your components, and test it. That would be the smart thing to do. You could also go straight to manufacturing and order it like I did and find out it's wrong. Depends on how much disposable income you have. So let's assume you're going to actually test it and prototype it first. Eagle does have a way to generate a BOM. I don't like it. In OrCAD, I like the way it's handled. You actually have a database. You set up the parts by hand. You put in all the information, and then you can click export. With this one, the way I saw it is you go to Design Link, I believe, Schematic, and it'll bring up this nice little menu here. And so you just look down here, excuse me, to find the components you want. So this is 10U. I know that's my capacitor. So we're going to do that. Yeah. And so I might need to narrow down capacitor ceramic. And of course we want it to be through hole. So let's just click through a little bit. See if we can find a nice, I probably should have specified the value too. I'm just going to pick one for posterity because I don't want to spend all day on this. And so you'd pick out each one by hand. Kind of wish I had pictures for this. Yeah, we're just going to pick them by hand. 300. That's good enough. That's an ugly resistor. That's an uglier resistor. We're going to go with the ugly resistor. This is another resistor. Yeah, I don't know why it doesn't like put in resistor for you. So you see why I don't like this thing.
So, can you try something real quick?
Sure.
Just for one time. I think this is like more time to put it together this week.
Let me go ahead and finish it because we can come back and do this.
So add, I guess, the ISA flag space.
Wait, what do you want me to do?
No, we had it.
Oh, no, that was first switch.
Oh, I'm sorry.
So 3.3K.
Put it in one, your favorite manufacturer. Yeah, that's cool. So the reason I mentioned this is because when you start getting open source parts, you're going to start having preferences. And this probably helps screw it up a little bit, figure out manufacturers, quality control.
Yeah. Personally, for this board, I already had the components picked out. I was actually doing the research behind the scenes, and so I already had 20 digi-key tabs open. So for me, generating that BOM there was not that hard. If you do it like we're doing now, where we're just kind of building it from memory, this can come in handy, but especially when you're trying to look for specific sizes and stuff, it seems like more of a pain than it's worth, in my opinion. If you get better mileage out of it, that's great, but then we can export this, and I think we can actually add directly to their linked shopping cart, and I forget which site they go to, Newark. And so they'll put it all in the shopping cart for you, and for a nice grand total of $16, you can get almost all the parts we need, with quantities and everything.
And if you go to, for instance, the website, Snap website, there's certain parts that respond to whatever manufacturer. It's all free tools that free and they want to use.
And there's the export, and I believe it just creates a text file. We'll go ahead and open it and view it, just so you guys can see what that's like. It's nothing fancy. Is this going to auto-open, or do I have to open it? I have to open it. Wait, no. You know what? I think I know where I can get to it faster. Control panel. There it is. Yeah. And this is the text file it generates. Why does it as a text? Probably because it works. So that's how you would generate it from Eagle. There might even be a way you can do something similar to OrCAD where you set up a nice little database of parts and have that as your BOM. I haven't played around with Eagle enough to answer that question, though. But let's assume you're a brilliant engineer. You designed it right the first time, no mistakes, no need to rip up traces and add external components with electrical tape, I think is what I used, because I am sophisticated. Or you properly tested this sucker, and so now you're ready to go to manufacturing. Easy way to do that? Yes. Just click that little switch button. And so there we go. We have our board layout. We'll talk about resizing that. We got all of our components just dropped there, ready for use. So this is where you would probably want to make sure you have your student license for this. There are limitations on how big you can make the board if you're using the free version of Eagle, and then you're also only limited to 2 layers. We'll go over that, what that means in a minute. Whereas in the education, I think you get up to like 16. I don't remember. And then the board sizes can just be larger. So let's start laying this sucker out. There's really no magic to it. You just grab it, and I would recommend you start by placing all of your components, get a feel for where you like things, and then we'll worry about routing everything. As a matter of fact, you see these little yellow lines. That's called a rat's nest. I don't know who was the humorous one that came up with that, but it's a rat's nest. And these will help us with routing all these various components later. So if we remember, LED is bit 1. So I think, based on my experience, I think I'm going to put the switches on the right side this time. And there is a design reason I'm doing this. So we're going to put those there. Come on. I see you're going to be difficult. Alright, the LED's not going to agree with me, so we're going to come back to you later. Man, nothing's working. Let's try highlighting it, then moving it. So again, if you want to rotate, I'm holding down left mouse to hold on to this, and then right-click rotates. So we're going to put all the LEDs like this. Doop. And then I'm actually going to show you guys in a minute how to align this. Where's my resistors? There they are. So while it doesn't technically matter, we are going to make R1 go with L1. And so on and so forth. Not going to worry too much about the alignment because we'll fix that later. And let's go ahead and put these resistors near their pull downs. We'll separate these a little bit. Boom. Boom. Which one are you? IC2. ICU. There. Come on, work with me here. This is a nice 6-year-old laptop, so it is of course mad at me that I drug it all the way back to campus after I graduated for a demo. Okay, and so this just gives us a nice little idea. One thing you may notice is that we got a lot of extra space, and so one thing we could do is reduce the board size. So let's start by checking what units we're actually in. We come over to the Design Manager. I always forget this step, or maybe it was under Layer Settings. No, that would be too easy. Options. I always have to find. It's one of those things you set once, then you forget about it the entire time you're designing it. Always forget where it is. Edit. Design Rules. There we go. So edit Design Rules. And so we're just going to start with a little bit of the basics. So these are the layers. Right now we only got 2. And what is a layer in a PCB? Well, you guys know that for electricity to flow it needs a conductor. Ideally in this case we're using copper. And the layer is just a layer of copper. So 2 layers would be top and bottom. That's the simplest, that's the cheapest. Eventually you may get to where your board's a little more complicated. For this one I overdid it and did 4 layers. There was no reason for me to do 4 layers, but I did it because I could. This is your layer thickness. Unless you know you need to worry about it, don't worry about it, because the manufacturer we're going to use, PCB Way, has their own pre-configured thickness. They don't actually care what we send them unless we explicitly tell them, hey, I want this to be this. And so a lot of this comes down when you start getting into more advanced PCB layouts. It's a bit more than I can cover. I don't even know the full depth of it. So we can just ignore this. So we'll come back eventually and show you the difference between using a 2-layer board and a 4-layer board, because there is a slight difference with how I would handle things with 2 versus 4 layers. Clearance is another good one. So we have our wire thickness, and the general rule of thumb that you have here, I believe it's for a 1-ounce copper pour, which I believe is what we're going to be using. 10 mils gets you is suitable for 1 amp of current. None of our components are going to be 1 amp. So 6 mils is probably going to be sufficient. If you know you're going to be using more than an amp, you might actually want to consider, hey, using bigger traces and things like that. But for this simple circuit, 6 mils should be fine. And same thing with pads. You got pads to pad, wire to pad. And so this has to do with the clearance as well. So if we come down here, so first off, wire to wire here explicitly is the clearance. So when we start laying out these traces, they'll never be more than 6 mils together. They'll always be at least 6 apart. Wire pad deals with that spacing via And you got SMD stuff. Distance, sizes, there's our sizes. So that's what I was talking about originally. I just didn't realize I was on the wrong page. That's minimum width, minimum drill, all that stuff. You can use the default and you will be fine for this. If you need smaller, then you know you need smaller, is what I'm trying to get at. And so that should be most of the stuff we'd want to have set up. I don't see anything unreasonable here. Maybe I'll bump this up to 10 because if you use a bigger wire size and lower tolerances, then you can actually get a cheaper board when you go to PCB way. Something to consider. But for actually changing the board, it's a little bit of a manual process. So I'm going to move everything over here. And then we're going to come down to here. We're going to select the outline. I think it's right. I right-click it with the info. Oh, and as you can see, I've managed to screw up my outline there. I don't know how I pulled that off. There we go. Control Y. Control Z saves the day. All right. So I have this right wall selected. I'm going to zoom in. I'm going to move it over. And there we go. I've resized my board. Now, if we want to view the size, there is a measure. I just need to find it. It might have been under here. There we go. Dimension. I'm going to select measure. And I'll explain these layers in a second, but for now, let's just test this out. So you guys saw that I selected this measure here, or dimensions. I'm going to choose horizontal. I'm going to select this corner very carefully. I'm going to come all the way over here and select this corner and bring it down here. So you're looking at this and you're thinking, okay, that's a nice number. What number is it? That's not what I meant to do. We come up here, select info, and select the, come on, let me select the dimension. Okay, you have a disagree with you first. You highlight it, then you click info. And let's see, there's the units. So the units are in milliunits. That's good, but the Adafruit was designed in mils, and so we're going to do everything in mils because we are barbarians. Mils, for those that don't know, is 1/1000th of an inch. So if we click apply, we see that this is 4.5 kilomils or 4.5 inches. Let's see if we can get this a little bit smaller, because I know if we can get this down to a 3x3 board, we can get the boards for $5 from PCB Way. So let's select this. Although it might be a little tight for space now that I think about it. Let's see just how tight we can get this. We might just bite the bullet and go a little bit larger. It's not much more expensive. I see we got some newcomers in here too. So my name's Blake. Did you two intend to be for the PCB Workshop?
No.
Okay. Well, you're in luck. This is being recorded, so it will be available online for you afterwards, so you can see the parts you missed. Right now, we're just trying to be a little bit cheap and get this board down as small as we can, because I'm on a budget. And what's up? You could. That is definitely a possibility. I don't want to, though. There's no other. I mean, that's my only justification is I don't want to. But yeah, you totally could technically run a wire between the two boards. As a matter of fact, they even, once we go to the manufacturer page, you'll even see a way that you can segment your board. So it is not uncommon to have like one layout with multiple boards, and they cut it in such a way that you can snap it and have multiple in one design. All right, this sucker's being difficult for me, so we're going to highlight and move. All right, let's see if we can get this to below 3. So, select. You'll notice that dimension isn't following it because those tools cost you a few $1,000s a year. I love how finicky it gets with some of its selections. I may just have to delete this measure and redo it. Okay, yeah, we'll delete that. Dimensions just work weird in this tool. They're more of like they feel kind of like an afterthought in my opinion, like, hey, here's a nice little thing you can use. So they're not as sophisticated as I would like. Let me right click you. Maybe I can press delete. There we go. Ha, delete key. So yes, you can right click delete, you can press delete, and you can use this trash can. So if any of those methods don't work, you're up the creek. Just live with it. Let's try and re-measure this. And this time we'll make sure that we're in mils. Horizontal. And we'll select. And select. And we're at 3.4. I feel like I'm already getting a little crammed. It's fine. I'll bite the bullet. This is good enough. I don't want to make this too complicated where we have wires going every which way. Yes?
So it might be nice to show how to put some text on here.
The text? Yeah, we'll get into the text. We're actually about to go to the hard part of wiring up that power supply. All right. So as I mentioned, we have that little power supply over there that I had to make by hand. I already got these measurements once, but you can imagine how I use that measure tool with the Adafruit schematic in order to get all these numbers. So let's turn on the grid, and I'm going to set these to 50 mils because most of those components were in 50 mil spacings. I'm going to display it. Where's my PCB board? So I'm going to start with this first pin. Where do I have it? Oh, did I not get the diameter of that? Well, how about that? I didn't get the diameter of that part. I got every other measurement but the diameter of the hole. So that's okay. We'll just show you guys how to do that. I think I still have it under downloads. See, I like to do the text after I've routed everything, so that way I know everything's where I want it. And then I worry about beautification. All right, there we go. So let's take a little bit of a dive into the layers here, because it's going to make our life a little bit easier. Just like in the schematic, you have a list of layers here you can select. If I come along here and say choose just top, you'll notice that I can select the red wires, but not the blue wires. So that's just a nice little filter, and of course you have this stuff here. What I'm going to worry about though is I'm going to choose this pad and vias. And then we're going to come over here into measure, and the only thing I didn't have was the inner diameter of this and this. So we're going to choose diameter. I'm going to zoom in here. I remember it being a nice round number. And then we're going to come out here, and this is probably in millimeters because I always forget to change these until after I'm done. There we go, so 40 mils. Yeah, it was just a nice round number. So our holes need to be 40 mils. Also, you notice how that's red? That's because I didn't do it right. Whatever you have selected there will be the layer it uses for the drawing, which only matters when we start generating the Gerbers. So if you do this and you generate it, it will actually generate this as a trace, which we don't want. So when you place dimensions, you want to switch this to the layer that you want it to be on. And of course, if we want to, don't do that to me. If we want to change this, then we'll just have to select it somehow. Oh, I had it. I know it is in OrCAD. I can't say I tried to do it in Eagle, but I'll bet you it is. So I bet if you go to layer settings, you turn off top. There you go. So layer settings, and this little eyeball lets you turn on and off layers. right, one more time. Come on. I just want to show these guys how to change a layer. Don't be so difficult. There we go. Control click. There we go. Info. And we can change this to dimension. And there we go. So when we go to generate the Gerbers, now that won't be generated as a trace. Any questions about that layer stuff? All understand that we need to have the proper layers, otherwise generations or the generated stuff goes awry. I'll get a sip here, my mouth is drying out. Okay, so now that I got that, we're going to consider this bottom line here 0, and these grid markers mark every 50 mils. And so I am going to 0.35 inches top. I'm going to go ½ an inch or 500 mils up. So we're going to click on this little via here, and the diameter, ooh, is this in mils or millimeters? I think it's in millimeters. File, layers, clearance, distance. Everything else is in mils. Can't remember what this is. I'm going to work on the assumption it's mils because everything else is. All right. So if it is, then we just need to set this to 40 mils. And then center of the board looks about here. We'll double check later. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll go here for now. And let's make sure we're right by double checking. Diameter, mils. I believe we'll set this grid to 5. Boom, boom. Okay, good. 40 mils. That's all I cared about, was making sure that hole is right. So let's see, 2.5 millimeter mounting hole, 6 inches apart, 3. And the pinholes are 0.1 inches apart, which is 100 mils. So we're going to come along with this via here. Where'd my grid? Oh yeah, my grid's a little small now. Let's put you back to 50. Or technically, we could do 100, and then we know that we just need to stick them like this. So since I'm using this for reference, there are 3, 6, 8 of these. So we're going to go 8 across. 5, 6, 7, 8. Now we're going to get these big ones. I don't think I got the diameter of that either. Well, let's go grab the diameter. So this was my process for laying this sucker out. Coming up here, measuring, and sticking everything in the right place. So why don't we just show that process, seeing as how I did not write down things as well as I thought I did. Clearly, I'm garbage at documentation. So we're going to start with this center to center. So these will be 350 top down. And then boom, boom, and 50 that away. Okay, and then we're going to grab one more. Boom, boom, 100. That feels right. Yeah, all that looks good. Let's go back to here. We're going to grab our via, set this to 100 mils. And we have our grid spacing for 100. Let's change that to 50. And this is more of a convenience thing for me. Just makes it nice and easy. So 350, that's going to be 7 down. 1, 2, 3, 4, 5, 6, 7. And then 50 that away. Okay. So is this process making sense for people? You guys see how I am laying these out, taking measurements, and kind of just setting my grid size to make things easy for me? No confusion on that? Good. So we'll just grab that, and that is 600 mils. Oh, that's going to be a problem. My linings didn't line up quite right. All right, that's okay. Back to 50. So let's see. 600, so 1, 2, that's 100. 200, 300, 4, 5, did I miscount? 6. Something feels wrong about this. Double check. 600. 1, 2, 3. Yeah, okay, everything else is good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I bet you have these wrong. I had it written down as 0.1 inch, but I'm willing to bet I have a typo.
The other model, so you went down to the left.
There you go. That is exactly what I did. Thank you for pointing that out. There we go. Team effort, guys. Team effort. All right, so that's looking pretty. I might go a little bit higher up. I think that might be good, though. All right, and so we don't have to put it, but I'm going to go ahead and put a little outline like I did here. And so this is kind of going to be similar to text. Let's do one other thing, though. Let's make sure I'm centered. So this is... What was the easy way to center? I don't remember. But I might be able to just cheat. Boom. It did help that I had this thing like 6,000 and I was able to just do it that way. So we're going to go here. I'm going to need this a little more fine so I get the exact center. So what is that? 17, 20. Oh, I thought I had you set to horizontal. 1725. That feels... Oh. Yeah, there we go. So that's going to be the middle. And so I was not quite centered. Let's do this. So this should be 300. And I didn't. All right, so I just need to shift over to the left by 25. I was pretty gosh darn close, though. I'll admit, I'm giving myself props on that one. That's pretty close.
It took us 3 hours, 3 days.
OCD. OCD. That's all I'm going to say on that. All right, delete that. And now let's add some lines. So we're going to select T-Place. T-Place is the name for the top silkscreen. So this is going to be that silkscreen layer where they start printing all the text and symbols and stuff. So I gotta select that. Then we come over to line. Let's see, roughly how big is this thing? 800 by 5500. We're gonna eyeball it. And since I know I'm taking a little bit longer, I'm just gonna lay this out all haphazardly and clean it up later. Because I don't want to spend all, because it took me way too long. I'm gonna admit, it took me way too long to make this thing look as pretty as I did. So I'm not gonna spend all day on that. But I can at least... No, I promised you guys I wouldn't spend all day on it. I'm not going to spend all day on it. I am spending all day on it. It's good enough. Okay, let's do one other thing. So I place these vias down. And when we click on them, if we look at their name, here, that's their net. We want them to go to our power net. And I believe it was just +5. Actually, let me double check, make sure that's the right one. No, that's the ground one. So this leftmost one is the ground plane, ground pin. Boop. And this one here is +5 volts. There we go. Okay, it all lines up. Beautiful. Now the fun part. We actually get to route this sucker. So we're going to click on the route air wire. And I'm going to go ahead and state Eagle does have an auto router. I don't like it. It just wires things weird, and so I don't like it. That's my only justification for not using it. Plus, wiring it up by hand, you get a little more familiar with the board, all that jazz. So that's what we're going to do. So let's start with some of the most complicated wiring, which will be our IC chips. So this first one here, where's bit 0? So you see I got nice little names here from our nets. There's bit 0. And we're just going to click and wire it up. This is another one of those things where you can spend all day making this as pretty as you want. I'm going to just try and get it done for the sake of saving time, because I will spend all day on this trying to get these traces to look pretty. So that to that. And we're going to go that to that. And then this will need to go to ground, but we're going to do ground a fancy way. I'll show you guys how that fancy way works. It's called a pour. This increment, we need to get to the switch. That one's going to be a little tricky, so let's do that first. What's the best way to do this? Okay, we're going to go under the chip. Some may advise against this. I say live dangerously. And I might flip those a little. Well, no, this should be fine. So we're going to, we should be able to just go here. Is this not, oh no, because it's on the other side of the switch. That's right. We're just going to get this sucker all wired up. Yes.
This would probably be a great opportunity. I think you guys see the amount of time it takes to clean this up. So why don't you take just a second to talk a little bit about the thought process and why you went that direction to be under the chip, which is going to take you a long time to finish this. For instance, you're going under the chip. And why did you choose to do that?
So that's a good point. I did go under the chip.
It's not bad.
No, it was a bit of a decision I made. Part of it was that I know eventually I'm going to have to start going to a second layer, because one thing, you guys can imagine how hard it would be to try and lay out every single one of those yellow traces on one layer. So eventually I will have to start going under. And so while I can, I'm going to try and get as much done on the top layer so that when I start using the bottom layer, I don't have to do as much bouncing between them. It can get to the point where you're saying, okay, we come up on a top layer, gotta go to the bottom. Oh, there's a top layer, gotta go to the top. And then I gotta keep doing that, adding vias. I want nice straight traces. Just for aesthetics, there is also some signal reasons as to why you might want to do that, but we don't have anything signal sensitive here when transitioning to a via. And so these are just kind of design habits I picked up. Avoid swapping layers as much as possible. And so under it just looked like a nice way I could keep these close together and get to this one, which is going to be, which would have been a pain to get to later. I could have gone way out here and made the trace longer and block up all these pins to where they now all have to go to the bottom layer to get to their next route. I think this just works the best in my opinion. Are there any questions related to that? Okay. So yeah, we do got a lot of pins. Let's go ahead and show you guys how to actually do a layer swap, because I don't want to spend too long on that. Let's pick a nice one that'll be a pain to get to. All right, so this bit 1. This bit 1 is way over here and needs to go way up here. Now I could take it and I could run it all the way around the switch. That makes the trace longer and builds up impedance, and I don't like the way it looks. Sometimes it is about aesthetics. So I'm going to take this, I'm going to attach it, and we're going to go this way. Oh, don't want to do that. So a good design rule you hear a lot is don't put 90-degree churns in your vias. I'm not going to argue whether or not that's a good rule or not. Some say it's archaic and doesn't need to be considered anymore. My boss doesn't like it, so I don't do it. Part of it is that it becomes a sharp point, and that can cause some signal issues. And I think I even read something about some sparking in high amperage situations. And so just don't do it. Try and keep it 45. And now let's try. And so I think this is where I get a little confused, because the shortcut in OrCAD is the double click. Let's see if that's what it was in Eagle. No, of course not. So now I gotta try and remember how to swap layers. I think you just, nope. Also, notice how this sucker is trying to wrap itself around when I get over here. That's part of the auto wrapping coming in. And so I think you right click. No, I get the fun part of trying to remember how this is done. There was a keyboard shortcut. Space. I'm going to make that a lot smaller because that's too big. 10 mils should be fine. Okay, so since I was fooling around trying to remember how to do it, if you press space, it brings up a via. Okay, I place the via, and then I'm instantly on bottom layer mode. So space is a nice shortcut to swap from top to bottom. Make sense? Good. Now, one thing that's nice about through-hole components as opposed to surface mount is I don't have to switch back to the top to connect to the LED. I can actually just come all the way up here and connect it because it goes through the entire board. If it were a surface mount, I would have to take that into consideration and make sure I get back to the correct layer. So that's one nice thing about through-holes. But you could also argue that's a downside, because with through-hole components, you can't stick two components on top of each other like this. Like I can't take this resistor, stick it on the bottom, and stick it with another resistor. They're touching.
So in another way, if you think about it, you can see the dual side RAM chips. Think about it, technically, so it's not components on both sides of the PCB.
All right, so we've shown how to do the top layer, we've shown how to do the bottom layer. Let's show how we do a pour. So eventually, over time, as you're laying this out, one thing you may notice is a lot of these components go to ground. And so I could wire these all by hand, which would take a lot, or I can just pour a bunch of copper. And so I want to say you choose the line tool. We'll select the top. You see, this is where it pays. You see, if I use this more, I would remember exactly where it is. No, it's polygon. Yeah, there we go, polygon. And so here's what I'm going to do. I'm going to take into consideration that I will eventually want screw holes in the corners. And we're just going to place those like so. So what I'm drawing now is the outline of my ground pour. So whatever is inside this bounding box will effectively just be a sheet of copper for all the ground stuff to connect to. And you don't have to be as strict with your 90-degree rule on planes. I'm not being as precise because I hadn't decided what kind of mounting solution I want to use yet. And part of that is because we might end up 3D printing a little box for this board. That's something I haven't completely decided. We may end up just using mounting brackets, so you got a nice little furniture ornament. So until that decision is made, I'm not going to add the mounting holes yet. But I am going to give myself the idea of, hey, I basically don't want these screws to be attached to the plane. And that may be something you want to do. I know there are, where I work, we do have some boards where the screws themselves are actually attached to the ground plane to ground the screws. So we're going to come all the way down here and attach it up. And this is ground. And so now all we have to do is click this little rat's nest, and there you go. You got a full-blown ground plane. And notice how it even leaves the spacing for the traces. See that? If we actually come and look, now all of these down here are attached. And so this could be another design decision, is how you want the plane to attach to these vias. This is fine. If you have a more current sensitive application, let's select these. I might be able to change it. Come on, I just wanted to select. No, see, I can never remember which layer it is. Well, that's going to be difficult. That's going to be some obscure layer that I can't remember what it's called. But this attachment here is just so it can get connected to the through hole. If it were a surface mount, and unfortunately I don't have a surface mount here, but I can go to my board and show you guys what a surface mount attachment would look like. But does the ground plane make sense to everyone? Do we see why I did this ground pour so that I could get connected to all of these quickly? Okay, good. So let's say you've taken your time, you've routed everything, and you want to make the text look pretty. So we all like pretty text, right? So I'm going to take the time to come up here and hide this. And I might even hide the rat's nest. No, I'm not going to hide the rat's nest. Nope, I thought I... Don't forget to click OK. So if we're going to add text, again, we need to use the T-place. That's for the top silk screen. So everything you see here in white is what will show up here. Make sense? So one thing I don't like particularly is I don't like to have component values, because I like the reference designators and using the reference designators to tell me what the values are. I leave them on the schematic, but I don't leave them on the board. So I'll remove that, and I would remove the IC chips names, and I'm just pressing the delete key. Another thing I might like, though, is I'd want to center this text. As a matter of fact, I think I'd like to put it below, like that. Now let's say you want to center this crosshair, for instance, because maybe you want to change the name later. What you can do, you can come down to this attribute, not the attribute. I will do this the easy way. We'll highlight it, select info, and so one thing you notice how that is offset to the crosshair? If we click on this align, you have some different centering options or alignment options for your text. So I'm going to do center center so that wherever this crosshair is, I know my text will be centered. And that comes in handy in case you change your mind and want to change it later. Reference designators we're not going to change, but what we will change, maybe, is what we call these switches. So who remembers what switch 1 is supposed to be? Yes, the increment. So we're going to come down here, and we're going to select text. I may have overlooked where the text is. There it is. I did overlook it. We're going to call this ink for now. Maybe I'll change it to be spelled out later. This is good enough. Let's place it in there. And of course, let's modify this a little bit. Let's get this nice and centered. I'm going to do bottom center. And if you look, you can also see we can change the size, other things, all that good stuff. So, you guys understand how text is added? And so yeah, at this point I could spend all day wiring this up, making it pretty, but I don't want to eat up your entire day unless you want to sit here and watch me lay up everything. So I will go ahead and point out some other things. Just some important things I'm not necessarily going to show. One thing to keep in mind with this ground plane. You could imagine that eventually these ground planes can become isolated. So if I get, let's just do a dummy example here. Let's do something really stupid. We'll say that I don't know. Oh, I do have to select something. All right, we do this here, and we do this here. Okay, so I'm having trouble getting it there because Eagle is keeping me from being stupid. But could you imagine that we could get the wires in such a way that we effectively form a box, and then that plane is no longer attached to the rest of the plane? Can we all imagine that? So a good idea is that if you're doing a 2-layer board with a plane, you would also want to put the plane on the bottom. And then everywhere you have isolated planes, you would stick these little vias so that they're connected, and that whole plane is a ground plane instead of just a sheet of floating copper, basically. Make sense? Good. So this is a 2-layer board, and as you can see, one thing I don't have is a power plane, which means that I will have to take this VCC wire and make sure everything is wired together by hand, which is going to be a lot. If you have a little bit of extra money to spend, you can get a 4-layer board and ignore that. And I'm going to show you guys that with the board I laid out. So we're going to go to my completed board. Projects, binary counter board. If you say it out loud, it makes the file navigation faster. Nah. Okay, I don't care. So some cool things. One thing you notice is that there isn't a seed logo on this. That's because I realized I could add a seed logo after the fact, unfortunately. But there's my nicely laid up here, and let's take a minute to explain this because I forgot about this. So you see the difference between this hole and this hole. This is a via, meaning there's exposed metal for solder to connect to and make connections between legs. This is a hole. That's the difference. It's just a hole. So no copper connections, no need to worry about stuff like that. And so if you want to add a hole, you come and click on the hole button. Spoiler alert, the hole button adds a hole of whatever size you specified. These, I think we saw, were 100 mils or something like that. I don't remember now. But I know these are M4. Why did I pick M4? I had M4 mounting brackets. So we'll just pick a random size here, do 40 mils. Yeah, you just place it, and during construction, when we create the drill file, and I'm going to show you guys how to do that in a minute, the PCB manufacturers will just bzz, and not add any metal to make it a via. Okay, so you see here I've got everything nice and lined up, but one thing you may not see is my planes. That's because if we come over here to layer settings, this, come on, is a 4-plane board. So if you weren't paying attention, you may have noticed that it went straight from 1 to 16 in the 2-layer board. But now I have this 2 and 15. Those are added manually by me. And so if we turn this on, you'll see that I have these little outlines. Okay. Let's rat's nest it so we can see everything. And there are my ground and power planes. So I don't have to manually wire up all the VCCs and all the grounds. Everything is just there. There's other benefits to this too. For example, during manufacturing, I made sure the ground plane was directly below the circuit. Why did I do that? So when you start dealing with advanced signal processing stuff, one thing you start to worry about is airwaves interfering with your circuit. And a good design rule is to put a ground plane below all your sensitive circuit electronics so it can help absorb that magnetic flux. So it effectively acts as a giant grounding antenna without actually turning your traces into antennas. A couple of ideas with a 4-layer board is that you either put both of these in the middle and all your traces are on top, or you have all your traces in the middle and 2 ground planes top and bottom. I did top and bottom traces so that you could see the traces, and then 2 internal power and ground planes. So just so everyone remembers, if you want to add more layers, you come up to Edit, Design Rule, Layers. And then you change this to 4. Now I took the time to also configure this to PCBWay's spec, just because I wanted to see if it did anything with the Gerbers. It doesn't generate an assembly file, and I didn't send them it anyway. So, but you can configure it like I did. And so a lot of that is just going to come down to what manufacturer you're using, what do you want, what specs you want to give them. So we understand the difference between 2 layers, 4 layers. Anyone need a visual explanation for what that is? Okay, good, good. So let's turn those back off. Okay. And while we're at it, we can look at the surface mount stuff here. So you see, rather than being through a hole like this, you just get a nice little pad. And when you actually manufacture the boards, I should have brought a clean board. I didn't think about that. I should have brought a clean one. But you actually get to see the exposed metal on the components. I didn't think about that. It's my bad. So let's say, also this is where my short is that I was telling you guys about earlier. This is where I had to physically scrape that sucker. So let's say you got to this point. Everything is beautiful. You're happy with how it looks. Your OCD is satisfied. It's 2 a.m. and you're just done. Now we need to generate the Gerber files to send it to the manufacturer. Super easy in Eagle. You can, for the most part, click Generate CAM Data and be done. At that point, yeah, you're done. Let's go ahead and take the time to show you what's actually going on there. So if we go to CAM Processor, these are the default settings. The ones you need to be concerned about are Gerbers and drills. The drill file tells the manufacturer where to drill for vias and holes. The Gerbers tell them how to set up the traces for the copper. It also tells them how the profile of the board, or the dimension, or the outline, and the silk screen. We'll pick on the silk screen top. So if we look, we have a little preview. And one thing you might notice is our beautiful seed logo isn't anywhere to be found. The reason being is we don't have it selected as a layer. So the layers for this one are T-place and T-name. If we want our seed logo, we need to add it as a layer. And I believe it's down here in the 200s. Bitmap is probably it. So because I don't remember exactly which one it is, I'm going to select all these bitmap ones. That's probably good. And there we go. So if you take a look at the preview and you see something missing, just make sure that your layers are set up properly. This will control what is shown here. So this is our silk screen. Let's also take a look at our traces. So we'll take a look at top copper. And there's our top layer. You see there's our switches, our IC chips, resistors, LEDs, and this is just the copper. So this is going to tell them, hey, wherever you see black here, I want copper. Everything else they're going to read. And we'll go ahead and also pick on one of the internal layers. Let's go copper layer 2. This is our ground plane. Yeah, they'll just put a giant ground plane and that will be removed in the drill file. But you get this set up, you do the process, Yes, I'll replace them. And then we will open the folder. There we go. We'll open the folder. So the stuff that you need to do is you need to take all the stuff in Gerber's, all these files, and, well, actually, minus the transcode report. That's something else. That's from ViewMate. And then that drill file. You take it all and you slap it in a little zip folder. I called it Gerber's. You can technically name it anything, but this will be what you upload to PCBWay. This zip file, and it will actually ask you some questions like, hey, what layer is this? What layer is this? And you'll punch in that information. We'll do that in a second. One thing that's generally a good idea, though, go ahead and check your Gerber's, just to make sure everything got generated correctly. So the way we're going to do that is with a tool called ViewMate. ViewMate, there is a free version. They try to shove the paid one down your throat because they want those extra couple $100. I personally would not recommend it. I've never used anything more than what the free tools provided. See, look at that. They're already trying to advertise stuff for me. I don't know what we're doing here. But anyway, there's the tool. I'm going to import Gerber's. And now I just got to navigate to that directory. Can I just copy? No, that would be too easy. So we're going to go to this PC, because I know it's not where I want it to be. It's in my OneDrive. I tried, it didn't let me. Or do I paste it here? Anyway. This is why I use the terminal. Too many complications in the GUI. And we're just going to select everything except the transcode and import. So there you go, guys. As we showed again, by 25, I still don't understand computers. Go ahead. We're waiting for it to load.
When you do like into your information, when you get stuff soldered, like what exactly you solder? Is it all components, or are there specific components that you can solder?
So PCBWay does have an assemble option. Why is this not importing? PCBWay does have an option for you to pay them extra, and they will put all the components on there for you. I've never used it, so I can't speak as to how well that works and stuff. Otherwise, you get it as is. That only gave me those. One of these files must not be a Gerber, and I just didn't see it. Something is not... I was accidentally getting the Gerber job in there. Gotta love those one little exceptions. Okay, there we go. So this is ViewMate. And this is what PCBWay is going to see when I send them my layer. So this is copper bottom L4. This is the very bottom of the board. And we can just go through, look at each one by one, and make sure we don't see anything erroneous. One thing I like to do is take a look at the silkscreen top, and then I'll right-click this top, turn it on, and I'll just make sure everything's lining up nicely. Okay, those are lining up, those are lining up. Just give it a quick little visual check, make sure there's nothing weird. The more times you check it, the less likely there is to be a problem, but it is not bulletproof. Case in point. Yes? So, for budget's sake, I believe our plan is that I will lay them out and we'll bulk order, but Myers may have an alternative. Yes.
This is a good problem to have.
I just had a follow-up question. If we lay them out ourselves, like how long
How many did you order first?
Minimum ordering through PCBWay is 5.
So that's, so you can look at 5, so maybe one of the scenarios that we got here. Our goal was to have second session, the version pretty close to this, and everybody can come back and actually do this particular one. If you've got another idea in mind, let's reach out, maybe we'll do 2 or 3 boards. The minimum order is 5.
Yes.
Discounts per board. So again, we've got a good problem to solve, and now we got to figure out.
Yes.
So like, I know we talked about power supply earlier, but like, order, like, PCB board on PCB way, do all the components come together in the package with the board, or do you have to order certain components separately?
You can order them from PCBWay, but I ordered them separately from DigiKey.
Okay.
PCBWay only ordered the board. And then the components I ordered from DigiKey, and I started for myself. The mounting stuff I just had. So yeah, personally, I would love if everyone could have designed their own board and we get them their own board made, complete. Some of them with faults and all, so we can go over, hey, this is how you might fix this issue and stuff. But we do have a lot of people, and I don't know if it's feasible for us to order 100 boards, 5 for each. Yeah, so one thing, I'm going to go ahead and point this out because this may be relevant to you one day. So the very, very first PCB board, yes, we're going way back to a year ago, board I ordered through the company. We laid it out, it was looking all nice and stuff. When I get to it, and there's a problem. My power and ground plane were shorted to each other. So we poured over the Gerbers, we poured over the schematics, we couldn't see anything wrong with it. We thought maybe there was like some hairline, so we even tried putting 20 amps through it, hoping to like blow that out if that was the case. And I don't have the Gerbers with me, and I don't think I could show them anyway for not NDA reasons maybe. But one thing that helps is that you would turn these both on. And you notice how some of these are purple, and some of these are blue, and some of these are red. If they're purple, that means they show up on both. If they're blue, they're layer 3, which I believe is power, and then layer 2, which is ground. On one of the vias for the microcontroller that was supposed to be for power was also shorted to ground. We're not really sure how it happened. We weird net routing issue on OrCAD or something. I probably messed something up. But yes, so the solution to fix that was to take the board, go to a drill press, and drill out the via. After we did that, it worked beautifully. So I don't know why that happened, but that's another thing you might want to check out. Just make sure your vias are routed to the right place. So you can turn them on and they'll mix the colors nice and pretty for you. And you can just give it a spot check. But let's say you viewed your Gerbers, you're sick of looking at this thing now, you're ready to order it. What you do, you go to PCB. Okay, good, it wasn't just my laptop. PCBWay. And am I logged in? No, that would make sense. This is why having 4 different devices you work on at once is great. You never remember what you're logged into. And we're going to get a quote. So here's the layout. Let me show you guys a little bit about how this works. So what I'm going to start with, let's start with a simple 3x3 2-layer board, or 5. And I believe you can just do a quick calculate. And so you see, you're paying the outrageous amount for shipping because it's coming all the way from China. But $5 for 5 boards, that's amazing. And then you get someone like me who's ambitious. So this was a 4x6 inch board. Well, no, that's the wrong way. It was 6x4. And it was a 4-layer board. Well, so we're just going to calculate that real quick. So because of that size, oops, wrong thing. I clicked on the wrong thing. Submit, calculate. We're waiting for this to load. Oh, I forgot the quantity. All right, so just doing a 6x4 already jumps you up to 35 for 5. So $7 a board, not outrageous. And then you get really ambitious and throw in 4 layers. Ha! Yes, autofill. So if you haven't done this before, you got to type this out by hand, and it's got to match your Gerber file names here. But if you're like me, and you leave your autofills on, you can just do that. Okay, anyway. I don't know if that's going to just recalculate for me. So yeah, after this, it would have been 103, but because of how many boards I ordered through my company, I had enough coupons that I got them for free. But anyway, so you do that, and you can just stick with mostly defaults. If you need something different, you know you need something different. 1.6 standard thickness. I think I left it as 6.6, so we'll leave it as that. It's not a huge price difference for that anyway, but if you go down to here, all of a sudden your tolerances jump up and you're paying twice as much for the board. So that's why the defaults are good. Minimum hole size, I think that's good. Yeah, I think, no. Yes, that's small enough. You can change your solder mask. I left it as green, but you know what? We'll do blue for this one. Why not? I'm not actually going to order it because this board doesn't work. We're going to do lead free. I mean, we could do gold, but I'm not that rich. 1 ounce copper, yep. All that looks good. So, unfortunately, Trey's not here, but Trey did ask about paneling, or at least he asked about paneling and not realized he asked about paneling. So he mentioned the idea of making 2 boards and connecting them by a wire. You can order panels where you specify how many designs are in a panel. So you can lay them up and then kind of snap them later when you're done. I've never done that, so I can't talk about how well that works. I usually keep mine just single. I like that simplicity. And this would be the assembly service that Joe asked about. So these are some options you can do. You would have to upload a bill of material. I don't know what their format is, but this would be if you wanted them to assemble the board for you. I don't know how I get this order discount. That might have been through here. And then the other thing is an SMD stencil. I've never used one because I don't have an oven. But the idea is you get a little stencil and you can stick it on the board and get solder paste, smear it so it goes perfectly on your components, stick your components on it, put it on a oven, a PCB oven, and cook it to automatically solder those surface mounts and stuff for you. It looks really nice on YouTube. I have never done it before. It's on my bucket list of things to do. So we don't need a stencil. But yeah, this is what you would do. You would lay all this out. And I'm not going to go any further because I don't want to accidentally buy another set of these. Oops, I accidentally have this stencil selected. How do I remove that? Well, it doesn't matter. There we go. So I'm not going to go any further. I don't want to accidentally spend another $100. But you would click it, and then you upload the Gerbers, and provided you never hear back from them, like they will send you confirmations like order received, order reviewed, order manufactured, order shipped, stuff like that. You do have the potential of hearing back, hey, you forgot to include the drill file. I'll let you know how I heard that one. Your layers aren't matching up, or one of these Gerbers doesn't match. They have some kind of auto review process, and they'll come back to you like something's missing and you just need to correct it. But assuming everything is right, you would upload the zip, it would go through their process, and you wait about 1 week is how long I had to wait. I think standard order time is 2 weeks. Oh, here we go, 4 to 5 days. Yeah, and it took about that long. But yeah, after that, all that's left is to wait for the stuff to come in and solder it. So do we have any questions at all?
So on that
Yes.
software, so I saw...
Which software? Okay.
It doesn't really have, well, it has a little. So it's that you saw that there was like a short for your board. Is
Yes.
there a way to run a simulation to
see if it would work?
Yes, kind of.
Is it worth the time and effort?
I tried hard to get that simulation to work with this, because hypothetically you could take this schematic and you could see where I started trying to add simulation components. I couldn't get the darn thing to work. I threw my hands up and called it a day. Because that was me. That was my stupidity. No, like, because this component wasn't built in, and so I had to go find it. I found some old file on a forum somewhere that had it working. I imported it, it didn't work, and so I had to dig up my LT Spice knowledge to know how to modify that file to get it working. I extracted the single component I needed, got it in. Oh, the nets don't match up. Okay, well, let's make the nets match. Hey, the nets match. What are you going to use for a button? I give up. So, hypothetically, there is a way. My personal recommendation, download LT Spice and do it externally, so that way everything just works nicely. There are some components that are a little too challenging to simulate, like a microcontroller, and the idea there is you extract the logic you want to test,